All right, the live stream is on. Record to the cloud is on. Okay. Well, I'd like to welcome everybody to the Building a Decentralized Application, dApp, Morgan State seminar. Today, Tuesday, June 6th, 2023. As with all Linux Foundation meetings, this is held on the Linux Foundation antitrust policy and the Linux Foundation Code of Conduct. Our technical oversight committee chairperson likes to say, be excellent to each other, which sums up our code of conduct. I'm now going to turn this over to Professor Emdad.
Thank you, Sean. Welcome. Hello and welcome. I'm Ali Emdad. I'm the director of the National FinTech Center at Morgan State University that serves not only Morgan, but also more than 60 other HBCUs around the country. I want to welcome all of you who are joining us today for this important webinar. We thank Sean Bohan, David Boswell, and Ry Jones for the constant support through Hyperledger, organizing a number of important and outstanding, I should say, webinars and workshops over the past few years. We also thank Jim Sullivan and Kyle Nielson of the Blockchain Academy for preparing this informative session. They will deconstruct and adapt and take us through different stages of the development. And we want to welcome again all of you and invite you to come back to the FinTech Center's website for a recording of this session and also additional information about the wonderful work that the Blockchain Academy is doing in educating and providing very informative courses and sessions. Without further ado, it's my pleasure to introduce Jim and Kyle.
Hey, thank you so much, Dr. Emdad. Hello, everyone. My name is Kyle Nielson. I am the Customer Relations Manager at the Blockchain Academy, and I'm going to share with you a little bit about the Blockchain Academy. So then we'll hand it over to Jim to walk us through this presentation. So the Blockchain Academy is an ecosystem, and we provide emerging technology education, specifically around blockchain, AI, Web3 technology. Our mission is truly to help the global workforce to engage with this technology and not to be afraid of it, as many people are afraid of, new things, and sometimes change can be a little scary. But we see a problem, and that problem is that there's a skills gap. And so we want to bridge that skills gap with not only technical folks, but also non-technical folks. The Web3 world is going to grow very rapidly and change a lot of the ways that businesses operate. So we will be certifying. We have a distributed platform that allows for this education to be utilized en masse. And by partnering with communities and universities like Morgan State and Dr. Emdad, we hope that we can propel the education and the knowledge of Web3 faster than it ever was going to be before. So I'm going to now pass it over to Jim Sullivan. He is our head instructor and CTO at the Blockchain Academy, and he's going to take us through this workshop. Thank you.
Okay. Great. Well, thanks so much to Sean, and thanks again to, thank you, Kyle. Thank you, Sean. Thanks, David of the Linux Foundation, David Boswell, Sean Bowen, Dr. Emdad, and everyone at Morgan State. We'd like to, again, extend our thanks to the Linux Foundation and Morgan State for sponsoring this this presentation. And we're happy to be here. As Dr. Mbad stated, we are going to start off with deconstructing a decentralized application. So then we will be moving on to a demonstration of the Ethereum Virtual Machine on Hyperledger Fabric, and we'll be making we're very happy to be making a special announcement about that and support for the EVM on the Hyperledger Fabric. Hopefully everybody can see my desktop presentation. Is that coming in clearly?
Yes. We see it fine. You're good to go, Jim.
Okay, so okay, fantastic. So again, we're going to be looking at running a running a smart contract and dApp, and we're going to also look at running that on Hyperledger Fabric. And as Dr. Mbad said, we're going to take the we're going to be deconstructing the decentralized application. So we'll take a look at it in that way. And so we'll take a look at all the parts, putting it together, the architecture, and we'll also provide links to a GitHub so everybody else can with this video and also some instructions that we're happy to provide. You'll be able to repeat all the steps. We'll also talk about why use the EVM for Hyperledger Fabric applications, briefly on that, and we'll look at the EVM support for Hyperledger Fabric applications. And then finally, we will have another demonstration of a distributed application or dApp on Hyperledger Fabric. And then we can talk about some next steps. So at the end of this presentation, you don't have to worry about this too much now. We will bring this back up again, but you will get the chance to either scan the QR code or navigate to one of these websites. There are 4 next steps, just so we don't want to present everything and then have you wondering what to do next. There'll be an opportunity to take some free courses. Also on take a Hyperledger Fabric course as well. Hands-on, completely self-guided tour. There may be an opportunity too for a live workshop. You can stay tuned for that. There is an access code, so as soon as you register, there is an access code, so you can be brought to these free sessions. Before we get started, let's just take a brief look again at the architecture of Hyperledger Fabric. So as everybody knows, Hyperledger Fabric is a consortium blockchain. So it's not a private blockchain like we think of a lot of times with either Ethereum or Solana or Bitcoin. This is meant to be used for business, for the enterprise. And it can either be for a single enterprise or multiple enterprises. So it really has a lot of value when a consortium of enterprises use Hyperledger Fabric. So we have our 2 enterprises here, or 2 organizations. And we can see here there are several peers, as you can imagine, right? There are several nodes that run on the blockchain network. And here is where the ledger is actually housed. So transactions are initiated by a client application, and then they are sent to the peers for endorsement, and also for ordering. And then all of the peers take care of again endorsing, signing the transactions. They reach finality, and then the entire ledger is updated for both enterprises. So sometimes you see organizations on an architecture diagram, and this is exactly what they're talking about. And there is also an ordering peer here that orders all of the transactions, because as you can imagine, order of transactions is very important when we are completing, right, when we're executing several transactions. There is a book, so please, if you get a chance, for programming in Solidity for dApp development. So please navigate out. It's called Programming in Solidity. And you can see here it is available, Kindle Direct Publishing. So if you get a chance, please navigate out to Amazon and take a look at it. And we will be updating it. It does need a little bit of updating, but everything in here is quite current. And please give us a book review as well. Let's take a look at a distributed application before as we get started. So a dApp, as it's often called, is a dApp stands for decentralized application. So the way the dApp is constructed is it has a blockchain component, and that is the distributed part. Not all of a distributed application is distributed. However, though, the smart contract that's running on the blockchain, that is absolutely distributed. So that is continuously running everywhere. And then what we do is we build a interface on top of the smart contract, and the interface can include other logic, and that part runs on a web server. Now, quite often, this is not decentralized. There are different ideas for making at least multiple copies of the web server available, and obviously that can be done with things like with different profiles you're able to contact. And we all know that a web server can be set up to point to several different instances. So there are many, many ways, many different levels to construct our decentralized application. Either way, though, it is a typical web application or mobile application that has a user interface. The user interacts with the web server and the web application. The web application has logic to actually call the smart contract, and that smart contract is running on every node on the blockchain. So if you're familiar with the architecture for web or mobile applications, you'll be able to pick up distributed applications pretty quickly. Really, the big difference is this layer, and I'm not trying to minimize it in any way. This is not trivial at all, the blockchain layer. But again, if you're familiar, there is a special code. We'll take a brief look at it that's able to call and interact with the smart contract on the blockchain. So you can go ahead and execute all different types of transactions, play games, exchange NFTs, create NFTs. So there's a lot of options you have with distributed applications. The way we start off is, first off, we need a smart contract. So there are many tools available for building smart contracts. As you can imagine, the Ethereum Virtual Machine, which can run on more than just Ethereum, you're probably picking that up. So that just like the Java Virtual Machine can be installed to run on many hosts, many environments, the Ethereum Virtual Machine can run on many hosts, many environments. We're not limited at all to the EVM. However, the EVM is popular. It has a large market share, and it has a rich community and a rich set of tools. So this is what we'll be looking at today. And one of the products that we'll be looking at, one of the tools is called Remix. And Remix is here at remix.ethereum.org. It is a browser-based IDE. And just like IDEs, it's built like most of the IDEs I'm sure you're familiar with out there, Hard Hat or Visual Studio Code. It's got a console, it's got an editor, it's got a file explorer. So we'll take a brief look at Remix. And Remix is where we will build our smart contracts. We'll start off in Remix, get them working first, debug, understand them as much as possible, and then we will take the next steps then to compile the smart contracts onto the blockchain. And some of the other tools that are provided and in our dApp, how we will deconstruct it, we'll be using the Truffle suite of tools. And one of the tools we will be using is Ganache. So there is I guess you could say, you could see Ganache if you look closely here. There is I guess you could say a candy theme when it comes to the Truffle suite. And again, one of the tools is Ganache. Ganache gives us actually a local blockchain. So we can install locally a blockchain, and that is also our Web3 provider. Within our browser, because we're going to have a browser-based application or distributed application, we are going to use MetaMask. which comes in the form of a web plugin. And we can use MetaMask for our wallet application, because most often you are going to interact with the blockchain with some type of a wallet, and you want that wallet to be convenient. There are lots of different ways to implement the wallet, but MetaMask is popular, and we'll take a brief look at how we can configure MetaMask for our browser and for our blockchain. If we see on here, if we look closely here on the Truffle documentation, one of the environments, or one of the tools, or one of the products, or one of the blockchains that is supported by Truffle, look at this, Hyperledger Fabric right on here. Core at one time, I believe they have dropped support, at least for now. They may be coming back, but we can see also Filecoin, Quorum, Tezos. So this is it's going to be quite useful to be able to use these tools on Hyperledger Fabric. So one of the things that we will be doing, maybe we'll take a look first, is we will be configuring, we'll be configuring Ganache as our Web3 provider, or our blockchain provider. And then we will have our smart contract compiled on to Ganache. So we're going to use Truffle. You can kind of see it in the background here. Truffle is going to compile that smart contract onto Ganache. And then from that point, we're going to have code. We're going to have special code, which is right here, which is going to be running, at least for right now, locally. And we're going to use this code to, first of all, build our web or our mobile pages, but also interact with our smart contract. If you look closely here, you can see Web3 provider, and we can see where the Web3 provider is running. And it has command line code for calling the smart contract. And you obviously can do much more than just call a smart contract. We'll also see an example there where you can interact with even other tools that are provided. You can interact like a full stack application. So say you wanted to maintain a list of users, you can have a local centralized MySQL database that you can offload some of the work to for maybe user login or other items such as that, or maybe to keep images in if you wanted to have some type of a search application. So you can have that multi-level type of approach, which is like sometimes we call that full stack plus. We have the database level, we have the web application level, we have the user interface level, and then we also have the blockchain level. So almost like a full stack plus approach. And we just looked at this, so we'll be putting it all together. So let's take a look at a live demo here of deconstructing our dApp. And you can see here, there is a GitHub link down here. This will be available to everybody at the end of this presentation, so you don't have to worry too much about jotting anything down quite yet. Let's take a look. So we'll first begin with Remix. So this is Remix, and let me just make this a little bit bigger. And this is our smart contract. So our smart contract runs using a very popular programming language called Solidity. And and if you want to learn more about Solidity, one of the sources is the book that we referenced at the beginning of the presentation. The name of the smart contract is Tally, and Tally does something really simple. It increases, so there's a function here called increase, and there's a function here called decrease. So there's an initialization, just like you would expect, and then we can get a count of a value. And our initial value is 0. So by increase, we'll increase it by 1. By decrease, we will decrease it by 1. So first thing we're going to do is come over here, and we're going to compile Tally. So that just ran. And what this does, it gives us 2 very important items. It gives us an ABI, which is an application binary interface. So Solidity doesn't execute on the virtual environment, on the EVM, or Ethereum Virtual Machine. It compiles down to a bytecode, and that's in the ABI. So if we take a quick look here, let's go, let's click on this again onto the clipboard. And let me make this a little bit bigger. You can get an idea of so this is actually compiled to a data structure or a data format called JSON. You can see the name value pairs there. So that's what happened with our smart contract. We can see the integers, how they're put in here, the inputs. We can see how they're indexed. And we can even see on here the function calls that are on here. And the other item that the compile, when we compile, gives us is something called the bytecode. And we'll be actually needing this, at least right now. We'll be going through this on Hyperledger Fabric when we get a chance, but you won't stay on that permanently. But there's our bytecode right there. So there will be ways to automate these processes in the future on Hyperledger Fabric. So for right now, this is we get the application binary interface and the bytecode. Again, you can see increase here that we have for our function. And if we look a little further up, you can see decrease there for our function. And so now let's go out here, and then our next step would be to use Truffle to compile this smart contract. So first thing we need is the next thing we need is a project. So our project, and unfortunately I can't make this any bigger, but we have a project here that we use, and we keep our smart contract, our tally contract in here. So the same contract that we will be running is right here on within our node project. And bear with me here 1 second before we move to this point. We want to go ahead and we also want to deploy this smart contract, and we want to make sure that it is running the way we would expect. So we can get our count value right now, clicking this button. The good thing about Remix is it gives us this once we have our smart contract coded and once we have it compiled, it gives us this user interface. It's really simple. It's not all that fancy, but they give it to us for free. So it's a great way to test our smart contract. And it also has a debug module as well. So we can get our current count at 0. Let's click on the increase button, and that brings back a success. And we can increase again. And we can also take a look at, get some feedback of what would be going into the blockchain, because this is the simulated output to the blockchain. Let's get our count now. So we've clicked on increase twice, and now our count is 2. And let's just decrease it once. And now get our count. All right, now it's back to 1. So we see here our tally contract is working. So great. So what we would do is get our source code, and we would go into our project, and we would put tally in here. Again, here's tally again. We can see it, and we would compile it onto the blockchain. And we'll take a closer look at all of these components here for our project. But so here's where we would access our smart contract, which is tally. And so we've already compiled it. So what we would do next is, just to make sure everything is running correctly, we would actually run the Truffle console. And this comes back. And the first thing we would do is we would create a new instance, because tally has been filed to to our Web3 provider, to Ganache. So let's take a look at Ganache. So here's Ganache running for us. So we can see here, we're going to be using this count. And what Ganache is giving us, again, is a blockchain. We can look in here. We can see the individual blocks of the blockchain. And it also gives us account numbers. So here, this is our public address. And it also gives us a private key here. We can also see a private key. And it also gives us some virtual currency to work with. So what we're going to do is, now that we have tally compiled, we're going to say a new instance. We're going to create this object new instance, which is going to become our our tally contract. So it is running there. And what we can do right now is we can literally type now new instance, and it brings back all this information that is part of that smart contract. But let's take a look at the address at, so the smart contract will have an address on the blockchain, and we can call the address. And look at that. So it brings back our address right here on our Ganache tool. And the way that we clear truffle is Control L. So we'll do that periodically. Right now, let's call a function. Remember that get count that we saw a little earlier? So we have new instance, and we'll call get count on it. And again, get count was right here. So we're going to call get, and it'll return the current count, which we initialize to 0. So what we'll do now is, since we used result, RES stands for result, we'll do result 0. And the 0 is actually right here. And I know this is hard to read. It's bringing back BN, which stands for big number. We don't always want big number, so you can call this function on here and convert it to a simple integer by just saying to number. And see how it just brought back 0 there. So now let's call increase. So we've already used result 0. So let's call our next result 1, and that'll actually create. So everything now, this increase has been essentially added to result 1. And again, we can return result 1, or we can call get count on result 1. Let's do that and call result 2, and let's call it result 2. So I know this part looks a little tedious. And we can see now it's increased from 0 to 1 because we call the increase. And again, we can do that same thing. We can say to number. I know this looks a little tedious, but this is all about constructing or deconstructing our dApp. So you can see here how we are actually able to call our smart contract from the command line. And you might say, well, why are we doing that? Because this is what our dApp is going to do. Everything that we're running right here is this is what the dApp is doing through source code from behind the scenes. Let's try one more time to run another increase. And again, that's we have result 3, and let's call get count on it. We'll just take the source code from up here and copy it in, paste it in. Oop. Oh, we shouldn't, we have to use result 4. Pardon me. That identifier was already declared, so we have to use result 4. And again, we'll call get count on result 4. So we'll do constant res4. So everything that we're looking at right now, this is the same thing our dApp is doing from behind this. Oh, okay, we'll make it res 5. And res 5 is now at 2. And one of the items that we would do is the 2 number again. We would probably put that again in our dApp, because we don't want a big number coming back like this for users. This is a lot for them to look at. And then let's try the decrease. So in order to avoid any kind of issue here, let's spell out the word result. And what I'm going to do is clear. And that'll be the decrease. And let's bring our count back on result 6 this time, because you can't reuse these. And then let's just try result 6. And that brought it back to a 1. So we can see our contract is working. But again, we can see here that now our count is back to 1. But this is a good idea of what's going on behind the scenes, because if we look back at our presentation briefly, we saw right here what's going on here. Well, this source code that's right here, this is executing those commands that we just saw. So it's important for us to know that in our deconstruction. And now that we have all of that running, let's take a look at a different dApp. So our other dApp is going to be called election. And one of the big use cases for blockchain is going to be voting, right? And not just voting in our elections that we have for government. It could be really any type of voting that we want to have. We want to get some data on, that we want to have. Maybe it's in marketing. It could be in many different contexts. So we want to be able to get votes, tally votes, but validate that they are fair. So this one, we have candidates. We create a candidate with our smart contract. Again, we're back here in Remix. We put some rules in here. We initialize some candidates. We have an add candidate where we add their name, give them an ID number. Candidate count is their ID number. But also we vote. And look at this, we're going to require that somebody has not voted, that they haven't voted before. So once you vote once, you get your address, actually a variable for your address set to true, and you won't be able to vote anymore. And we'll actually just, because that's the one big rule in the smart contract that we want to validate that is working. So let's, again, so we've coded up in Solidity. We have a vote function. We have an add candidate function. We have a constructor to initialize. So notice it's calling add candidate here and adding all of our candidates for the ballot. And then we are using these functions here just to build up some data structures and to make things public out to the log. And again, we will put a user interface on here so we can capture the tally easily, because this is obviously not all that user friendly. So again, we'll click on the compile. Already ran into an issue here. Oh, look at this. Let me just. Okay. Bear with me here 1 second. Let's see if we can get another copy of this smart contract. Going to a different browser. Okay. So we can see here election, and we'll click on the compile here. And again, we have the ABI and the bytecode, and we are able then to deploy. And again, we can see our candidates. So we know who our candidates are. We can see candidate 1. We can just put a 1 in here and bring back the information on that candidate. Notice this candidate, who is Ryan Williams, this is a little hard to see. The vote count is 0. And let's look at the vote count for candidate number 2. Also vote count 0. And maybe for candidate 6. Okay, all vote count 0. We can look at our current candidate count is 6. And here we can actually put in an address here on the voters and bring back that information. I don't want to just go up and copy the address, but we can also bring back the different addresses for the voters. But let's actually run our vote application. So again, we put in a candidate ID here. So suppose we want to vote for Bryant. Put in candidate number 2, click vote, and that was successful. And now let's take a look at the vote count for Bryant. Put in candidate number 2, and now notice it's up to 1. Suppose I try to vote again. Suppose I say, I don't want that. So this is the big test. So let's come in here. Suppose I want to vote for candidate 4 instead. I click here. Now it's saying, oh, I can't vote anymore. Now it's 0. So we can look here, right? And we can see, and did candidate 4 get my vote? We can put 4 in, and the vote for candidate 4 is still 0. So that rule is being enforced here on the blockchain. I can't vote again. So now what we would do is we would take this source code, and let's take a look again at it, and then we would look to build up a project. And we go in here into election. And here is our smart contract here, the same smart contract that we just ran and tested. All in there. And what else is here? And we actually have that source code. So we can come in here, and there is this source code that now calls this smart contract once it is deployed. If we take a look here again, we can see a Web3 provider. If we look down here, we can see the election is the contract is actually being loaded. The candidates here are being listed. So you can see here we can return candidates. So those same steps we were going through, those fairly tedious looking steps, this is called Web3.js. This Web3.js is actually executing those same commands in order to build our dApp for us. And one other thing that I like here is we have we also have the HTML, which builds that initial presentation, that web page. So we're going to call this the coolest kid in the class, the coolest kid election results. Some other things that Truffle can do for us. Truffle can actually run testing for us, which some of you may be familiar with unit testing. So unit testing validates that all these functions are still running. So we're actually able to call the vote function and then pass in what we think the results should be, what the correct results would be. And then maybe some error messages in the event that a bug gets introduced, because a bug can get introduced, right, to our applications, and we always want to make sure that they are up and running. So we can see here we are actually calling on the vote counts. So we're returning that. I like this. I like the testing. We can continuously run the testing. Let's take a look at an example here where we can type Truffle test. And it's going to go into our test folder. And I already compiled this. So it's saying everything is up to date. But here, I don't know if you can see it, it's actually running the tests. So we had 4 passing tests. Oh, we had 1 failing test because I added a different candidate, so the vote counts are off. So Ryan Williams was not expected in those tests. But this is good, right? Now you know, okay, now I have to go in and update my test. So I have 4 passing tests and 1 failing. And we can continuously validate that this is still running, right? That whole idea of regression testing is there. And all those same good practices from software development are still here in the development of our dApp. So now we see that what is our dApp made of? Well, it's made of Truffle here. Again, let's remember this account here, 6315, and it currently has 98 Ether in it. And so we've already run our tests. Let's take a look at our browser. So MetaMask, we talked about earlier, is going to be providing the wallet. So we can see here that we have 97.99 Ether, and there's that 6315. It's kind of hard to see, but this is now MetaMask is pointing to Truffle here that's running on the desktop. And again, we can see these blocks here of our blockchain, our virtual blockchain. And this is a good thing to do. It gives us, gives users, test users the same experience as the live blockchain network. It allows us to test and validate before we spend some real value out there on the network. And it's really fast. So these types of tools are available to the EVM community. And another, it obviously is another great tool that you'll be able to use on Hyperledger Fabric very soon. Let's go back in here to Truffle. And let's start up our project. So let's clear this. And we are using Node.js. So in order to start this, it's npm run, in this case, dev. And notice there also are a few dependencies here. And let's just take a quick look here. If we go in, wrong one. Go in here to election. There are some dependencies right here. The one good thing about this dApp that we have built, it's relatively simple. If we look here, we only have really one dependency. Let's close that too. And that is, I opened up the wrong file. That is the light server that we just saw light up. And you can have a lot of dependencies, but then you've got to make sure that none of those dependencies get deprecated. So this is the one that we use a lot for learning because it tends to be very robust. And that all is part of this project here. And we also have the README file that's right here that explains to everybody how to run it, right? And npm run dev. But I am going to stop it for 1 second because I do want to take you through at least a simulated compile. Just clear this. And let's call Truffle. And instead of compile, we're just going to do migrate. Migrate does do compile, and it also migrates it to the target. And the target we have set for this is a local target. You'll see in the feedback. So it compiled our contract. We also had it set for local host. So it's compiling it to the local host. And if we look closely here in our contracts folder, we can see today's date right in there. So we actually, in a way, recompiled, and we're getting all this feedback here. So this is something that we can expect to see. So now let's clear this again and do our now let's go to our browser, and in this case it's going to be localhost, and it's with Node, it's running on port 3000. So we can see here our smart contract, and again, just to remind everybody what this should look like, we have these candidates. So we see here Ryan, Bryant, Sean, Alan, Paul, and Jimmy J. So these are all of our candidates here. And all of our smart contract, notice there are no votes, is surrounded by some of the items that we put in our HTML and in our Web3 JavaScript. And then we have our drop down again with our candidates. So this is how we're going to vote. So I wanted to vote for candidate 4 last time. I accidentally voted for candidate 2. So let's vote for candidate 4 this time. And notice our addresses right here, our identity. Our identity is coming right here from the blockchain. So I need an account on this blockchain, and nobody else will know the private key and the public key. And also, we don't know who this is. So this is just ours. So we can click vote here. Let's just refresh this, resynchronize. Okay, there it is. Now MetaMask is opening. It's asking us to confirm. We click confirm. And now we get back the results. So we can see here, Alan has 1 vote. And take a look at this. I cannot vote again. So this ID right now, at least in this election, has no other way to vote. And this is permanently reported. And we can take a look here at the blocks. We'll see that there was a new block just mined right now. So we can see June 6th. It's kind of hard to see, but this block by 47 was just mined right now. We can go in and take a look at some of the details if we wanted to. But this shows us the simplicity, right? This is a real deconstruction here. We're looking at kind of a lot of the internals of dApp development. So, and here it is running here. So let's take a look at these same principles over on Hyperledger Fabric. So just give me 1 second here. I'm going to stop sharing here, and I'm going to just bring up a different desktop with Hyperledger Fabric. Okay, can everyone hear me now?
We can hear you, Jim.
Yes, Jim.
Okay, great. Let me share my desktop. I'll be there shortly. Okay, so we're very happy to announce that we will be bringing the new maintainers for the EVM. This is our first announcement here. So the On360 team, powered by the Blockchain Academy, are the new maintainers of the Fabric EVM lab, which is right now it's a lab. So it's got to make its way up to a product, but is the Fabric EVM library. So look for that there. We expect that to be out very soon. We're still moving through the application process, but we will be, again, supporting this. This product had gone end of life. It was previously known as Hyperledger Burrow and had gone end of life. But the EVM is so ubiquitous, so popular. The community is so big. We thought this was a real gap, not having this available for Hyperledger Fabric. So we were very happy to be able to bring this back to the community to allow all EVM developers and the tools to be available on Hyperledger Fabric, because again, it has a lot to offer, and Hyperledger Fabric has a lot to offer. So we saw that as a gap. So we're very happy to be to be the maintainers of this product, and allowing the same process that we just saw for building and deconstructing a dApp, and then building a new dApp, or building other Hyperledger applications using Solidity and EVM. So we're really happy to be part of it. A few things there. Again, there are tools that are still currently use what was the old product for the EVM. We can take a look here. Products that their documentation still contains the instructions to use the EVM and Hyperledger Fabric, and we can see here the Truffle Suite still uses Hyperledger Fabric EVM for EVM. So we can see here that we can use that same Truffle Suite. We can see, we will see the exports that are part of the project using port 5000. We'll take a look at that. We'll actually see that how we use port 5000. A few things. We won't go through the whole installation process. I've taken you through a lot of command line activities, so I don't want to bring everybody through that again. But we will actually see on here there is a container on Hyperledger Fabric where EVM actually runs. It's called EVMCC. If you look closely here, you can actually see it here, EVMCC. We might take a quick look at it. Then we're actually going to use Node.js and Web3 to work with the smart contracts on Hyperledger Fabric. And again, we can see here, we can use it natively as well. So for native type of applications, or work with Node.js and Web3. So it does work both ways. You can, obviously, we have Remix available to us on for our Hyperledger Fabric application. So one of the great, we'll actually be running a contract, we'll demo a contract, and then we'll actually run that on Hyperledger Fabric. But we'll have Remix as that visual development environment. And again, we can see here we have natively in Hyperledger Fabric. We can see here that we are running the Ethereum Virtual Machine, and we're also we're running it natively right from the Fabric container, right from the peer command line, and we're also able to get into Web3 and Node.js running on the same host. And here you can see the big numbers that we just saw. And this is a what else? This is the same type of architecture, only involving Hyperledger Fabric, where we will have a Web3 proxy here, which will be running our Hyperledger Fabric. And again, which will be running our dApp, and we can see here the Fabric EVM library is supporting that. So let's go in and take a look at our demo before we get any further. Bring that down. That's all. I'm just going to put the presentation back up here for 1 second while we back on here. Just going to pause sharing for 1 second.
Hey, Jim, you have not paused sharing. We can still see the screen.
Let me see what I'm sharing here. Okay, yeah, that's what I want. I just want to just bring this back up here. I just had to for whatever reason restart this instance. It became a little unresponsive.
Not a problem. We can see currently your PowerPoint deck.
Okay, great. So let's resume sharing here. And so let's go through some steps here on Hyperledger Fabric. So let's exit this. And clear the screen. Now I have a few little items over here that we'll go through first. So we already have our Web3 provider running. So if we look here, we can see, let me make this bigger. So this is running on port 5000, and this is our Web3 provider. And it's actually running out of this window right here. If you look closely here, this is running what we call Fab3. So this is the EVM running on port 5000. You can see it right here. Let's take a look here at Remix. And what we are going to do here is we're going to run an application called Student List. And so you can, again, see our source code right here. And we're going to run this out of Hyperledger Fabric. So let's do our compile here of Student List. And let's do our deployment. And we can create a student, or we can mark a student as absent. But here are our initialized students. We have 4 of them here. And we can create a new student. We can call them Ryan Williams. And let's bring back let's bring back some information on student number 1. So we see Tim Baker. Notice Tim Baker, the present flag is set to false. So we'll toggle that a little bit later. Now we have a student 5, which I believe is Ryan. Now that came back. And let's create another one called Kyle. And that should give us student 6. Okay, so now let's go in and we know that student 5 is currently marked as, or student 5 here is currently marked as absent, because so let's make student 5, let's mark as present. So let's mark Ryan as present. And this flag now should become true. Yep, it is. Same thing with Kyle. Let's do the same thing with Kyle. And now when we run this now, the present flag should be also true for Kyle, which is great. So what we're going to do is take this same contract that we see running here, and we're going to deploy it on to, we can see this running on our environment here, Hyperledger Fabric. We'll go through these steps. Now for us, we're going to have to use the ABI. So in our compiler here, we're going to have to use the ABI and the bytecode. So that's going to be really important for us too. But there will be obviously tools for us in the future, in the very near future, just to make it a little more friendly. So we already have EVM loaded, but we said we'd take a look at it. So let's open up a new terminal and make this a little bit bigger. And we'll conquer and make this, we stretch this out. We can see one of these peers says EVMCC right here, and that is our Ethereum Virtual Machine that's running. So let me close this out so we don't have to get those interruptions anymore. And so that's where, and we could see all the rest of the Hyperledger network. Remember we saw the peers at the very beginning. Here's the orderer. Here is the CA, and we also have our EVMCC here. So that is that's going, and that's also working with the Fab3 or the EVM provider. So out of this window here now, let's type, let me make this a little bit bigger. And let's just type node here and start Node.js. And the next thing we're going to do is we're going to create this Web3 object. Now, again, this is the same thing that our dApp will be doing, and we will get a brief demo of the dApp. Okay, great. So that's returning our some feedback, and we're going to set that port 5000, that application running on port 5000 to our Web3 object. And again, what's running here on port 5000, this is our EVM provider. And that always has to be up and running. at least in the background. Again, here it is right here on localhost on port 5000. So that's key. And even what we saw earlier, we can return our accounts, and we do have to set a default account that is required here. So paste, so now we have an account here, and we do have to set a default account. So we'll use that default account that came back. So we'll copy this in, paste here. And what we're going to do is take this account that came back right here. And we're going to set that as our default account. Great. Okay. And Control L clears the screen here. So now we have our account set up. Now we're going to use this ABI. So this is the same ABI that we got from here where it says ABI for the smart contract. So this is how we're going to deploy the smart contract. So right now we're not using any tools. We will be able to use tools like Truffle shortly. So we just, this product needs just a little bit of maturing. It is running. It was end of life, so it just needs a little bit of maturity, and you actually see the Truffle suite. So we can use tools like that, and so we can actually skip this step. Well, we wouldn't be skipping this step, but we would be using a tool for this step. But essentially what we did was we took the ABI and we set it equal to this simple storage ABI. And next we're going to take simple storage. Well, shortly we're going to take simple storage ABI, and we're going to add it to our simple storage variable. Our simple storage bytecode, we've got to also get the bytecode because the ABI and the bytecode are very important for deploying our smart contract. And we actually need this bytecode now, and I already have it right here. So I'm going to just hit and I'm going to copy it into the buffer. And the bytecode's really long. Oh, good, that worked. Okay, that's always a toughie there in any type of a demo. Ooh. And so now we have our simple storage bytecode. So now we're going to create this simple storage object, and we're going to pass into it our ABI that we just set shortly, or just that we just did just before. So see simple storage ABI. So we're going to create this object, simple storage. And great, that worked. Now we're going to deploy our smart contract. So this is the deploy step. So we're going to deploy the ABI and the bytecode. We're going to run this command to deploy. And sometimes it's a little slow. Okay, great. So that ran. Now we're going to create a smart contract object that we're going to call smart contract. And this step here, remember we needed the contract address. We definitely need the smart contract address. So let's do a Control L here. And this step, we still have to go up and find our smart contract address. Again, we won't have to do this with tools. The tools will return, so tools like Truffle. But this is our smart contract address right up here, which we'll just copy into the buffer because it's a little much to. And into our sheet here that we're using. In our next command, we'll need the smart contract address. Okay, good. And we'll save that. Great. So now we're going to define our object, our smart contract object. Remember we used new instance a little earlier. Instead, we're going to use my contract. And let's do a Control L. Paste, and now we're going to create, now all that simple storage, which included the ABI, the bytecode, it's at this address, and now we're going to use my contract for for that object. Oh, great, that worked. So let's do Control L now, and let's call some functions. So my contract, hopefully everybody can see this clearly, dot, and remember students. And let's return some information on student one. I believe that was Tim Baker. Ooh, look at that, Tim Baker. And look, Tim Baker is set to false. Let's bring back some information on student number 3. And we sometimes, at least on this version, it throws a little error on the endorser. The endorser here is part of the Hyperledger Fabric network. I guess what this is good is it's showing this chain, or this is actually chain code, or this is actually code that is running against all of the nodes in Hyperledger Fabric. So no doubt about that. But if you're a little persistent, there it is. It comes right back. And we can also do the add students or create student in this case. So it was a create student function, right? Let's take a look. Yep, it's definitely called create student. So let's make sure that, I know we had in this demo, we have to type it in, but we'll actually see a dApp where we are rendering a web page shortly. But it is still my contract dot create student, and it gives us that. And it has to be a string, so we can send it, we can pass in Ryan Williams. And if it returns an error, we can do it a second time. And now Ryan is there. And we can also do one for Kyle. And okay, great. So we can Control L that. And let's bring back student 5, just so we can figure out where we are. Okay, student 5 is Ryan. Okay. And we can also bring back student 6. Okay, and we can see that that is Kyle. Another thing we can do is we can do the we can run that instead of 2 number, we can also do 2 string in order to make it a little more friendly for our application. And we can see down here, let me Control L that and see if we can. So see how this came back now, where it's just 1 string of text. So we can see that Kyle is student ID number 6, the name Kyle Nielson, and we can see Kyle is currently set to false as far as absent or present. And we can, these are just some of the commands that are out there right now. And if we look at our smart contract, let's take a look again at our smart contract. It's a toggle present, and then we pass in an ID. So let's do, again, let's bring back maybe student 5, get a status on Ryan as well. So there's Ryan. We see Ryan, the flag there is set to false. So let's mark them present here. My contract, and in this case, it's going to be toggle present. And so we put in a student ID. So we know that for Ryan, student ID 5, because we can see it right here. Come back. Okay, that ran. So if we run again the details, we should see now this for Ryan, for student number 5, for Ryan Williams, the flag is now set to true. And it is. All right, fantastic. Let's do the same thing for Kyle. Let's do a Control L though and clear the screen. And toggle present, this time with 6 in there. on my network here, my Hyperledger network, things are running a little slow today, so everybody bear with me. And again, this is the types of commands that will run in our dApp, and it will actually our web page and the code that we use, that middleware code, is actually going to be doing this for us. Okay, great. That came back. And again, we can bring back the details here on Kyle, but we have to pass in student number 6. And we see, oh, okay, so the flag now for Kyle is set to true. So that is how, so again, when deconstructing our app and on Hyperledger Fabric, same idea. We have a smart contract. We can use now that we're using the EVM, we can use Remix and we can get everything working. Again, we can deploy this. We can create, we can bring back details here on student number, say 2, right? We can see this all comes back. Rob Sims. I don't know if you can see that, but the present flag is set to false, and Rob Sims is student number 2, so we can toggle present, and now we should see that it comes back as true. So once we get the contract working here in Remix, and we do the whole compile steps that we just went through to compile the contract to the EVM provider here in Hyperledger Fabric, and we are able to work with our both with the tools and the EVM, and this is the beginning of our dApp. So let's take a look now at a dApp. Let's keep our fingers crossed that the little error that we saw doesn't come back to get us. So I'm going to bring up the dApp now. That takes a little bit to run, but we'll go over that. So what I'm going to do again is pause sharing briefly. Let me bring up our, in case anybody wants to take down any information. Oh, it's right here. Put this up slightly. Pause sharing. So what we can do is use that same type of contract code to bring back or to build a web page that actually calls the smart contract. Just set this up, and hopefully everybody can see my screen again. Looks like you can. Let me know if you can't. Let me make this a little bit bigger. So zoom in. Just resize this. Okay, so the same roster. Let's and this part sometimes runs a little slow. Okay, good. So it's opening our application. And you might recognize, I don't know if you've ever watched me give a demo of this before, I tend to reuse the same CSS, same style here on the web page. Try restarting it here one more time. Control C. And looks like this is giving me a bit of a tricky time today with the yarn. But we will, why don't we open it up for questions right now? And we'll see if we can get this back up and running short. We can see if we can get this back up. Why don't we open it up if anybody has any questions right now?
Super. Hey, Kyle, do you want to lead on questions or would you like me to?
Feel free to take it away.
All right, cool. The first question, and these are going to be in the order when they were received. Benjamin asked, is layer 2 also supported in what we're doing with EVM Hyperledger Fabric? And I'm
yes. So all of that will be supported. Yes. So the same as what was supported previously with the previous product, it is also going to be supported with with the new product. Absolutely.
cool. Dawood on YouTube asked, and I think we've answered his question as we went on, but I'm confused here. Ganache is for Ethereum protocol / blockchain, whereas the Hyperledger Fabric is for private permission networks. How come both are the same? And I think I then explained that this was a workshop about deconstructing dApps and the fact that we have the new EVM Hyperledger Fabric lab starting up. Next up, go ahead.
We will. There is going to be support for it. It won't be the exact same support, but there is going to be support for Ganache and for products like that. So it might not be the exact same, but it's still going to be. There is going to be support for tools like that.
Cool. Andrew asked, what about the marketing and tokenomics, which would be needed for a dApp?
Well, it's going to be a little bit of a different experience with Hyperledger Fabric. So all the same use cases that you would use for Hyperledger Fabric are going to be the same use cases you would use the EVM for. So it's not going to be like we're going out now to a public blockchain and using Hyperledger Fabric. It's going to be it will be a different experience. It will still be an enterprise blockchain. It'll be an enterprise blockchain that is using Hyperledger Fabric.
Cool.
And it'll be an enterprise blockchain that's using the EVM.
Lacoste asked why, and this goes back to when you were doing the demo portion of your presentation, Jim. Why is Res 1 added to Res 0? And
it's because those objects with Truffle, once those objects are used one time, you can't use it again. So if we call get count on a result 1, when we are when we do another get, it has to be, we can't reuse res 1. It's just one of those syntax things. So once that variable, it's when we say let res 1 equal a certain amount, we can't go in and reuse it. That's all.
Cool. Ram asked, was the smart contract deployed from Remix to a local instance of Ganache? He was somewhat unclear about using both Remix and Truffle.
Oh, well, we both, on both demonstrations, it was local, yes. So everything was done right within the context of my computer.
And where was it deployed?
It was deployed locally as well.
Locally
so the smart contract was deployed to Ganache.
Awesome. Anthony asked, will the smart contract source code be shared with participants? I don't think.
Yeah, we have the GitHub out there. So
we have the GitHub out there. Super. Okay. And I will put a pin in that because I have a comment on that in a minute. I think we have 2 or 3 more questions that we can check on the demo. Are there any startup projects like Scaffold-ETH in Hyperledger in regards to dApps? I would say that the new lab, Jim, do you want to talk a little bit about that?
Well, we will have equivalents to that where we won't have that right away, but we will have those. We will be featuring tools like that. Yes.
Awesome. Getting to the most recent question, Shulkor asked, this blockchain thing, can we master it with no programming to a little programming knowledge?
Well, we have a very simple example, but you also will need, but for the more complex, obviously, the more skills you have, you're going to be able to build. We're going to be able to put those skills together to build dApps of greater complexity on Hyperledger Fabric.
Awesome. And before we go check on that demo, I would like to do a shout out, and I don't see her on the list of attendees anymore, but Ashley from UNC Wilmington was in the chat answering questions. And that was really awesome. And I really appreciate her doing that because she has knowledge about building dApps and she was sharing what she knew. So that was brilliant. That is it for the questions that we've captured so far, Jim.
Okay. All right, good. Well, yeah, it looks like I'm having trouble here in my virtual image of the networking for whatever reason. It's not connecting. The virtual network isn't connecting. Just trying to go through the steps here to get the do we have anything else? Anybody else? Kyle, anyone else want to share anything before while I just do a little bit of troubleshooting here?
Yeah, just wanted to extend another thank you to everyone for joining. And we are going to share documentation with everyone who has joined. We will share links, relevant links to the communities, to the presentation, to the free courses that we're providing to everyone. And thank you. If you have any questions, please feel free to reach out to any of us. We are at your service.
Just trying to get the reboot here and get the network back and running here. It seems like for my Hyperledger dApp, some of the I used some of the libraries that require internet access, and my virtual network is not up and running. So I apologize for that, everyone. Now just trying to do this reboot here.
Not a problem. While you're doing that, I am sharing in the chat. I've done it a couple of times so far, but we got a couple of links in here. The Morgan State FinTech Center, the Blockchain Academy, as well as free courses, a link to free courses for seminar participants by the Blockchain Academy with an access code. Programming in Solidity. This is the book Jim shared at the start, written by Jim, available on Amazon. The wiki page for the seminar series. So this wiki page, we've done 3 of these so far. One on the business case for decentralized identity, one on the technical underpinnings of decentralized identity. So the business case was more, I'm not really for the business students, but for folks who are not necessarily engineering focused, but on the concept and the business case for it. Whereas the technologies involved, the second seminar was really got into the not hands-on weeds, but like what are the components that make up decentralized identity within the Hyperledger ecosystem? So Aries, Indy, the Open Wallet Foundation, etc. The next link on this set is a wiki page for this seminar. That wiki page, once this ends, the Blockchain Academy team are my new favorite workshop givers because they got me the deck before the workshop started. I'm going to put that on the wiki page. We're going to grab all these links. We're going to have the YouTube video embedded there, and I will make sure that Tanisha and the FinTech Center get the video and all the links as well to share with the students who were able to join us. This is still being live streamed on YouTube. We turn off comments on YouTube just because we get bombed with nonsense sometimes, but you can always check in with the Hyperledger Discord, as well as Hyperledger's GitHub. And the last 2 links that are on there, the GitHub is covering all of our projects. So the graduated projects like Sawtooth, Fabric, Indy, Aries, the incubated projects, things like Anon-Creds, Bezu is one of the graduated, but Anon-Creds, Bevel, now called Cacti, Firefly, and a number of projects under the incubated tag. And then we have labs, and the labs are really where community members can raise their hand and say, hey, I want to do X with Y and Z. And as Jim mentioned before, this new lab that they're launching actually started its life back in 2017 as a project called Burrow. Fun fact, they became a project the week after the project that I was working on, Indy, was added to Hyperledger, which is pretty great. But the Burrow team moved on, and bringing this lab back is actually opening up a lot of capabilities, both for interop and working with Ethereum, but also for ways for folks to participate in the community. So we're super excited about that new lab getting approved. Are there any new? Where do I get a hold of the document? Glenn, we are going to have all the links on the wiki page for this seminar. So the slides, links to the GitHub repos, links to places like Discord if you have questions, etc. Someone asked me about the first page of a concept of dApp. MC might want to check the recording after. Professor MDAD, give a note. That's great. Oh, and Gary made a comment. There's an increasing move towards low code, no code programming. I would say the work that Jim's been showing is not low code, no code, but as an industry, we are moving that way. So
yeah, I agree with that. And there will be products that actually support the EVM for low code, no code. So you will be able to use them for Hyperledger Fabric. As a matter of fact, if we go back right here, this I can show you right now. This product was actually a low code, no code. Let me just see if I have a. Right here, let me start sharing again. This product right here is our the Simba chain. Actually does support Hyperledger Fabric, or has in the past. If you look at their documentation, that is a low code, no code product. Now I like low code, no code. I'm not trying to say I don't like it. You are limited, certainly, right? There's something behind the scenes generating the code, and you're entering some type of a model. So you're going to have some limitations with low code, no code. So it's not always the answer, but yeah, we really like the product. So we want to be able to support low code and no code, no question about it.
And as someone who used to work in a number of startups, low code, no code means you can prototype, you can test ideas really quickly, which is exciting. Before you get down into, let's do a fully dressed architecture review and figure out where we're going. You can play around in low code, no code, which makes it fun. Mm-hmm. Jim, any luck on that?
Let me try one more time.
No worries. This happens to me too, man. It's all good. New messages. Sorry, somebody.
Yeah, my image virtual network seems to. Try one more time. I tried connecting to a different Wi-Fi. So let's see what happens here.
And while Jim's doing that, if you want to watch the video again or share it with a colleague or friend or roommate or coworker or fellow student, you will find it in the Hyperledger YouTube channel, which is the live stream link, the direct link for the live stream is up there. If you go to the Hyperledger YouTube channel, I have issues with this, other people don't. You have to click on the live tab. The live tab will take you to this and other events that we live stream. It doesn't automatically go into our videos section. That is something that frustrates me greatly, but that's what they decided to do, and that's okay. Let me see. I will put the link in the Zoom chat right now. And
yeah, no luck. It looks like I've got to have my network connection is not working here, but this would normally this would render that student smart contract, but for whatever reason, the components here, some of the styles or something need internet access, and my image for whatever reason right now is not cooperating. So I can't even get to Yahoo or Google or anything like that. If I go out to Google, I can't get to Google. So I just have to check with the networking here on this image.
Are there any other questions for Jim or Kyle? I don't want to leave anybody out. I'm going to check, actually, as I say that, I'll check the YouTube to make sure no one else is asking questions there. And there is the QR code there if you want to scan it and get access to the page that the Blockchain Academy set up. We'll also have all this stuff on our wiki, and we'll get it to the Morgan State team as well.
Again, thank you so much.
Yeah, we'll look to follow up with a demo of our. Maybe we'll somehow attack it or get it out somehow to our presentation that's out there of this running here. Yeah. We apologize. Sometimes that's one thing you have to make sure that like anything else these days, we use JavaScript. some of the components, some of the libraries do have to have external access. So that's the.
No, it was great. Thank you. Thank you so much, Jim.
Thank you, Jim and Kyle from the Blockchain Academy. Thank you, Professor and Tanisha from Morgan State FinTech Center. The special access code, Glenn, if you scroll up in the chat, it's there, but it's also going to be on the wiki page on Hyperledger's site. Give me a second, Glenn. I'll post it. But I want to thank all those folks. This is a seminar. We are planning additional seminars for the fall semester, as well as possible workshops. We got we're working on what are the workshops that would have the most impact for the students and faculty at Morgan State and the other HBCUs. But thank you everybody for joining us, and thank you to everyone who asked questions and was attending and watching. Again, this is going to be on. Here's the free course for seminar participants. I just put it in the chat, Glenn. That's not the right link. Hang on one second. This has been really great. We really thank everybody for joining us, and we hope it was valuable. There we go.
All right. Take care, everyone.
Have a good one, everybody. Hey, Glenn, check the chat. I just put the access code.
Thank you, Sean. Thank you for coordinating. Thank you.
No worries, everybody. Have a great day. I'm going to stay on here for another minute or two so folks can copy and paste things.
Oh, okay. Bye-bye.
Thanks. Thanks, everybody. Glenn got it. All right, good. Okay, let me check the YouTube stream. What are the questions there? All right.